Every secure web app answers two questions: who are you, and what can you do? In this module, we'll separate authentication from authorization, then connect sessions, cookies, and tokens to real access decisions, the foundation for passwordless and blockchain-based identity. You've already seen how blockchains protect data integrity through blocks, distributed ledgers, and consensus. Now we shift to identity, how web apps recognize users, verify them, and decide what they're allowed to access. Before an app shows a dashboard, saves a setting, or accepts a payment, it needs to make an access decision. Who is this user, and should this action be allowed? Authentication and authorization often work together, but they answer different questions. Authentication proves identity. Are you really the user you claim to be? A password, security code, or biometric check can help prove that. Authorization comes next. It decides what that verified user may access or change. Logging in does not mean full access. Strong systems check both. First, who you are, then what you're allowed to do. Consider Alice logging into a web app. Her password is correct, so the app recognizes her identity. That is authentication. Then she tries to open the admin area. Now the app asks a second question. Does Alice have the admin role? If she does, she gets in. If not, she is blocked. That second decision is authorization. A login request begins when the browser sends credentials, usually an email and password. The server does not simply trust that request. It compares the submitted values with stored account data, typically using a safely hashed password check. If the match is valid, the server creates logged-in state, such as a session or token. From that point on, the browser includes that proof with later requests, so the user stays recognized without retyping credentials. HTTP forgets who you are after each request, so login has to create proof the browser can keep using. Think of it like receiving a temporary visitor badge at the front desk. After that, you show the badge at each secured door instead of checking in again. In web apps, that proof is usually a server session ID or a token, and it must be protected because whoever holds it can act as that user. In a server-side session model, the browser does not carry all the user's details. After login, the server creates a session record with information like user ID, login time, and permissions. The browser receives only a small session ID, often stored in a cookie. On each request, that ID returns to the server, which uses it to look up the session and decide who the user is and what they can access. Cookies are a common way to carry a session ID. Once the server sets the cookie, the browser automatically includes it when talking to the same site, so the server can recognize the user without asking for a password again. Because this happens automatically, cookie settings matter. HTTP only blocks JavaScript access, secure limits sending to HTTPS, same site reduces cross-site abuse, and expiration limits how long the session remains valid. Tokens offer another way to prove that a user has already authenticated. An application can store a token and send it with later requests. A JWT is a common token format made of a header, payload, and signature. The payload holds claims, such as the user identifier, role, and expiration time. The signature lets the server detect changes, so a tampered token is rejected. But signed does not mean encrypted, so sensitive secrets do not belong inside the token. Sessions and tokens both help an application. Remember who is logged in. With sessions, the server keeps the real login state, and the browser sends a session ID. That makes central logout and revocation straightforward. With tokens, the browser sends a signed credential containing claims the server can verify. Tokens work well for APIs, mobile apps, and distributed systems, but revocation needs extra planning. Once identity is known, authorization decides what the user may do. Roles provide broad access, like admin or editor. Permissions are more specific, such as deleting a post or viewing reports. Ownership adds context. You may edit your own profile, but not someone else's. These checks can combine, and they must run on the server. Hiding a button in the interface may improve the user experience, but it is not security. Authorization must be enforced where the user cannot tamper with it. The browser can hide an admin button, and that is useful for clarity, but a user can still manipulate requests or call an API directly. Every API endpoint should authenticate the request, run middleware, check permissions, and only then read or change data. The backend is the enforcement point. The front end is only a convenience layer. Passwords are familiar, but difficult to secure. People choose weak ones, reuse them, fall for phishing, and lose them in breaches. That is why modern systems increasingly move toward passwordless sign-in. You now have the core model. Authentication proves who someone is, authorization decides what they can access, and sessions or tokens keep that state alive across requests. You also saw why passwords create risk. Next, we'll build on this with public key cryptography, the basis for passwordless and wallet-based identity.